Okay, welcome to another one of these screencasts. I'm going to be working on combat training again. And the last one we ended off, I basically talked about this MinIO console, which is a UI that you can use to look at your MinIO storage. What I didn't realize is actually, let's open this up, is that this actually already comes with console running. So this container that you run for MinIO, 9000 is the API, 9001 is your MinIO console. And you can see here's the command there to include it. So I don't actually need to do anything extra. There were a few things, and I've also gone and fixed up a couple of things, some small things which I'll run through just to show that everything has been put together. So the first thing is that I needed to add a root user and password to MinIO, and this is so that I can access the console. So basically, you can go to your localhost 9001 and you get this screen, and then you need to log in. So you're going to use those credentials. And here you can see is the repos bucket that I had created earlier, or in the previous screencast. And right now there's nothing in it. And this is what I wanted to show, that everything has been put together. So if I take one of these URLs, submit this, and we go back to the console, there it is, right? So now we can see that the folder actually is being uploaded, and there are all the files in their correct folder paths, exactly like the repository. And I've gone with the naming convention of the username underscore repo name, because that's going to be unique, at least coming from GitHub. It's not 100% unique, and I could add some kind of prefix or a suffix on the end of this that's like my own unique identifier as well. But yeah, so this is fine. Now, one other thing for MinIO is that I also needed to create an access key. Actually, let me go back here. So let's go to access keys, and then there's my access key, right? And you can set a policy as well, but I didn't need to do any of that. I just created one access key, which comes with a secret key as well. So if you go to .env, I needed to change those credentials then to use those, not the default that comes over here. Right? So here it's MinIO admin and admin. Once I added these credentials in, I needed to create an access key and a secret key, and everything is good. So in terms of uploading to MinIO, everything there is looking good. That's all done. Now, in terms of the logic for the job to actually upload these files, I had just made some small improvements here. So the first thing was on the trigger, I can specify a schema which helps with at least giving some types to the object, so that way I know what the payload is going to be, and you can see it's a repo URL or an object with a repo URL property. So at least with that, I don't have to do any of that what I was before, which was like data equals to payload as something, right? So I don't have to do that. At least now I know what the schema is, which is great. And then we have the clone repo, which has some additions as well. So first thing I'm doing is I'm getting the folder name from the URL, which is just using a regex. It's on github.com specifically, and I know that you could also have other sources like GitLab or your own self-hosted GitLab. So this isn't perfect, but it's fine for the moment. And then here it returns the username and the project name in that folder structure with the underscore. So it returns that, and that folder name is then that's where we store it in the temp. So if I go to here, right there it is in the temporary folder. And then that's also what it will get uploaded to MinIO as the root folder for that repo, so that each repo is stored in its own folder. And then I return it here, and then we pass that into the upload folder method, where I needed to make one small change here, which was to just pass in the relative path for the object, so that when it gets uploaded into the correct nested path. It's true file path. Otherwise, you just get all the files in one folder, which is not the point. So we're maintaining the entire correct folder structure, like the original source folder, and those are the only changes there. So we have those changes I've gone through, and what else do we have? So this was MinIO. We've run through get service, and yeah, okay. So basically, we are able to upload. I can close some of these, and we can take a look. I can close simple get as well. And so we're now at this point here where we are storing the repo in MinIO, which is good. So that's like step 2 is done. The next step is to embed the files. So I'm going to need to look at the Milvus documentation. So let's go to the docs here, and let's go quick start. There's actually a Node.js SDK, so probably it's going to be better to just look at their documentation. View quick start over here. Okay. So in the meantime, I can just install this. And we'll go through what we need here. So there's some code examples here. LangChain example, Next.js example, so that could be useful. Basic usages. Okay, so then you also need to connect to Milvus. So here they're creating an app.js file and adding the following code to try out some basic vector operations using the Milvus Node.js client. So you have your address, username, password, create a client, and then here, this is to create a collection. Prepare data, insert data, create an index, and then search. Yeah, so quite a few things that we'll need to do. Okay, this is the configuration for Next.js. And they also require this copy Webpack plugin, which I wonder why they need that. It's to copy from here. Okay. So let's go through everything. This is the app folder, public. Let's see. Create a server page component in pages index. This component will interact with. Okay. Oh, this is the public one. App has page. Interesting, yeah. Doesn't seem like this has the example that they wanted to have. But okay. Okay, so page.tsx. So here import basically the client, create a client pointing to some address. And here they're just getting metrics. So not really anything to do with the vector stuff. And then this is just going to be a layout, nothing interesting there. Okay, so that's not probably a great example. This seems like what I should go off of. So I'll talk a little bit about the embedding process. So basically we have those files. and we're going to create an embedding of each of those files and have to store those in, I would imagine, what they call a collection. So you'd have a collection, probably, let's see, like collection name. The concept of a collection is like the table in traditional RDB. Okay, so the collection will store all file embeddings then. I was just thinking that it should be an embedding, a collection per repository, but that is probably overkill. So you could just do a collection for all repositories, and probably what you can do is you can upload, or you can insert records with metadata, and in that way you can filter out the records when you do like a filter. So for example, you would have, let's say you inserted 10 records for all the 10 files of your one repository, and then when you're working with that repository in the app and you want to do some kind of query on those files, when those files were inserted, they were inserted with the metadata that it relates to a specific repository, and it'll include the repository name, ID, other sorts of information, and then you can say, filter by that metadata so that we are only querying on those specific records. I'd imagine that there's probably something like that to do. Probably if we go here to the search. So here, this is a vector search. So we have the collection name. Then this is the vector, the actual search vector. Filter, height. Okay, height is probably, yeah, these are optional filters. Search parameters. Okay, the limit. Yeah, okay. So then the way I think this will work is because fields is being passed into this create collection here, and the schema is, it's actually a list. Okay, so each this schema here, each object is a field or column. Technically, in the traditional databases, this is one column, which is the primary key. This is the next column, which is the vector. The next column is the height. The next column is the name. So those are the attributes. You've got the age, the height, and the name, and those get stored. So here, when you're preparing the data, you have a vector that you insert, the height and the name, and the ID is auto-generated, so you don't have to include that. And so these are all the records being inserted. All right, so you insert those those rows basically, and then we create the index. So this is can improve the performance. Yeah, of course. And it's a HNSW index, which is great. So create the index. There's other types of indices as well. And okay, load the collection sync. So when you create a collection in Milvus, the collection data is initially stored on disk, and it is not immediately available for search and retrieval. In order to search or retrieve data from the collection, you must first load the collection into memory, which makes sense. So before you do the search, you have to load it into memory. So we call this. Now you can perform the search on your collection. So you have to include the collection name, of course, and then your search vector is the other piece here that we need to see how to create the search vector, which they probably have some kind of embedding method to help you do that. Okay, so let's get started with connecting to Milvus. This package is now installed, and I'm going to go and do the same sort of thing I've been doing here with all the services. So this will be a Milvus service, which, you could go with like embedding service. I think is probably just a bit more generic. So here, this is going to be constant embedding service, and we need to initialize everything here. So Milvus client, okay, we need address, username, and password. Connect over here. I can export the client. So these values need to come from our environment variables. So we can do environment, and then we're going to need to do like Milvus address, environment dot. They don't exist yet, but Milvus username, and then the same thing, environment password. Okay, so these ones, let's go over here. And these are all going to be strings. The address is with the port included. And then also put all of these over here. Okay. We need to grab these from the .env file. So this will be Milvus. This will be localhost. Let's go open that Docker file. So this is MinIO. Standalone Milvus here. Okay, so MinIO address. Yeah, so 9091 probably. Okay. Username, let's just go back here. Don't think there were any. Yeah, I'm going to leave this optional then, I think. So let's go to the environment file here, and we'll do optional. I think is probably the best. Yeah, which basically makes it undefined. Oh, the address is not optional. The address is required. Yeah. Okay. Okay. So you've got that. That's the first part. Second part is to create a collection. Now, I don't think we're going to be abstracting the create collection method, meaning that users will be creating their own collections. At this moment, I don't think that'll happen. So this will have to be done once, and then we just insert into that collection. So I'll create the function here. So this will be create collection. Collection name is required, yeah. So it's going to pass in the collection name. Okay, then fields is going to be a schema, which is this here. Dimension, and yeah, all of those there. I'm going to call this the create repo collection. And basically just do it like this. Okay, so collection name will be repos. I think that's just the easiest way to do it. And then the schema we're going to need to change here. So what fields do we need on this table? We'll need the repo. I mean, we could store the repo URL, or the repo name rather. But you know what? This is actually not right. We need a collection that stores each file name and the file content, and then the embedding. The vector is a vector of, or is an embedding of the file content. Okay. We probably need a file name, file content, and then we also need like a foreign key. not a foreign key, but it's like an identifier. Yeah, that maps to in our DB in some way. So meaning every file, because we're gonna have to store each file path of a repository, but that will be stored in our own database. So there's a bit of database planning here that I need to go through. I wonder if it's actually easier to just do it here. Let's see. Is there like a database planning tool would be great. But I guess I have to do libraries here. Okay, it's fine. Let me just do it down here. Okay, so let's say that this is the main DB, and this is vector DB. Okay, there's some things that we need to store in our main database, and there's some things we need to store in the vector database. The vector database is obviously going to store the embeddings, right? Like we've just seen the vectors, right? So if we have like a vector table, that's going to be basically a collection, like they've named it, okay? And it's just going to be one collection at the moment. So we can effectively think of this database as like one table within a database, let's just say. And each row in this table is going to have a few things. So it's going to have its unique ID. Then it's going to have the actual vector, the embedding. It probably would store the original file content, I guess. This might be overkill though, because we're already storing the file in MinIO, so kind of questionable if we wanted to duplicate that. And then I'll just call this metadata. So metadata would basically be things like, let's say, what would we want to store about the file? Like maybe like the size of the file. It could be like a generic summary. Anything you want to store. Just information about the specific file. Okay, so this is going to be like one row. Right, one row is one file of a repo. Okay, hopefully that makes sense. But now the thing is, this is all fine. Like we're storing this all in vector DB, but now we need to have some way of actually, in the application, being able to retrieve, or the user being able to retrieve or search the rows that they want to search. And so, for example, definitely the repo ID needs to be stored there, that's for sure. So imagine this would be, okay, our main DB repo table. All right, so you create a repo, and let me get this whole thing here. Okay, and then just fix this up. Okay, so this is our repository table. So you put your URL in, you click save. It's going to create a repository, right? Because you need a record of like things that you've created. So it says, okay, you've created a repository. It's going to have the ID. It's going to have the name. It's going to have maybe the number of files, all this information, right? We also need, well, then it's going to go through each file, and it's going to create those rows in the vector DB, right? but it needs to be able to reference this back to the repository table. Like we need to have a relationship here. But this relationship, because it's spanning across two different databases, is maybe not as intuitive as if it was just another table in the database. Because if we had another table that was like vectors, and we were storing it ourselves, then we could have a foreign key that references the repository for those vectors. But here the rows are stored in a completely separate database, so it's not actually a foreign key, but it kind of behaves like one in the sense that we can do a lookup and know which rows relate to what. So here in the metadata, and I don't think we'll actually store file content. So here will be repository ID. Okay, so repository ID is probably one of the most important concepts here, because it will link to this row. Right, so we'll be able to then know what all of these vectors belong to. And then the point is that then I can go and search, and I can say filter, where's the SDK? So we insert all these rows, and then here we come and, okay, this is creating index, load it into memory, okay, and then filter, right? So height, this is really cool. Being able to do a filter on properties that you've stored, I mean, it makes sense, right? Like being able to filter by properties of the table. So here you can say, height is greater than 0. What we'll do is we'll put like repo ID equals whatever the repo ID is. So that way we just completely filter out all the irrelevant records there, and we just use the records that are of interest to us. And then the rest here, you can get output fields as well. So it's pretty cool. Okay, I think we know what to do now. All right. So let's, if we just revisit, let's keep this open. All right. So for the vector DB, which is all of this, we have the ID, which is going to be, they've used this as the primary key. I'm going to call this ID, and then this is ID field. Data type is integer 64. Is primary key is true, auto ID. Okay. Then we need a foreign, effectively like a foreign key. So this is going to be the repository ID. This actually probably needs to be, this needs to be lowercase probably. I'll do repo ID like that. It's like a foreign key, basically. Int 64, it's not, is primary key true is not necessary. Auto ID is also not necessary there. Okay. Next is the vector. All right, so this is fine. Dimensions, 8 dimensions. I'm actually, we'll come back to that. Okay, then we have, I wonder if we can actually do, if we can do JSON data. Data type dot, what do we have here? Binary vector JSON. Yeah, amazing. Okay, so I'm going to do JSON here. This is going to be metadata. Max length, I mean, this is going to be quite long. Okay, what other fields do we have here? Yeah, ID, vector, repository ID, and metadata. So the rest here is not really useful. It's basically height. So those are the fields we need: ID, repo ID, vector, and metadata. Okay. All right. Let's see what other methods we should handle as well. So this was prepare data. Then we have insert. So let's do async insert. Collection name vectors made. So this is going to be, I'm going to add a type here. So we'll say rows, which will be an array of rows. And then I'll say here the type of a row is going to have to map to that. All right, so if we take a look here, it's got vector ID. Vector ID is an array of numbers, so that's good. They had height and they had name. ID is not necessary. Repo ID we need, and then metadata is, yeah, this is good. So this should be fine. Okay, then collection name needs to be a string. All right, so we do await client insert on the, this is going to be collection name. Fields data is going to be rows, and yeah, the types work out, so that's good. Yeah, so they let you just give an array of an object with whatever. Okay. Then we have, so that's the insert. Then we have create index. So that's insert method. Then we can do create index. And this one's pretty self-explanatory. The only thing here is, so the vector field is what we're doing. Index name, I'm going to do repo index HNSW. I'm going to keep it with this type of index, and I'm just going to leave everything as a default for now, and then just clean all this up. Okay, so that's creating the index. Load collection sync. So let's call this load collection. Okay. And vector search. So all right, so the search vector, this is field data of 0.vector. Now I don't really want to okay. Oh, that's just an example. Okay, right. So we're going to need the collection name. We're going to need the vector, right, which is a number array that's going to get passed in, and then collection name like that. Required. This is to compare, and then these are optionals. So the optionals, and we can return this as well. So I'm going to include the repo ID here. This is a number, and here we'll do this. This will be repo ID. This has to match the name of the field here, repo ID, and it's going to be, I think, probably equals to, like that. Search parameters limit 10, I think, is probably, that's quite a bit. So yeah, let's do 4. Metric type L2, optional metric to calculate similarity of two vectors. Yeah. Output fields is going to be, let's do, oh, well, of course, the height and name, these are other attributes. Of course, we're going to need to have the file content. We're going to have to have the file content. Okay. Yeah, so we need another one here. This is a string. Okay, so basically just coming back to here, we can just make this smaller. Okay, so content is the file content, right? We need to have that stored in this table. And okay, file content stored there. So what we want is to get the content, output fields, and I mean, we can get the repo ID as well. Now another question here on the schema is, what if you have an extremely large file? So if your file is pretty big, you might actually have multiple embeddings or vectors per file, and that you mightn't want to even do that. You might want to chunk each file. So what I'm thinking then is, you've got the repo ID as well, but probably you're going to need a file ID as well. Yeah. So here, let's do that. All right, because you might say, if the file, let's say the file length is like 1,000 lines or 2,000 lines, you might say you want to do some kind of chunking, like text splitting on that content, and then embed that file as 10 embeddings, let's say like 10 rows of 20 lines. Or you can chunk in different ways, but the point is that I'm not going to assume that you do one embedding per file. It's obviously going to be based on the file length. So update this as well. I'm going to need to make this bigger. Okay, so we've got metadata here, and we've got content, and we've got repository ID, and we've got file ID as well. Okay, so this also means in our main DB, this is going to be two things here, and this is actually the opposite way around. This is going to be main DB like this. So we have the repo table, and then we have file table. This is also going to relate back to the repo ID, or to the repo. So you've got this relationship, and then you have this relationship as well. And you've got this relationship as well. All right. So basically saying that the vector relates to the repo that it belongs to, but it also relates to the file, right? Because you could have multiple rows per file, and all those rows ultimately also belong to a repo. Okay. All right, so I think we've got enough here to go and start testing this out. So the first thing is we need to create this collection we need to run this command somewhere, and then we need to start using the insertion. The create index, I believe, is only going to happen once. Yeah, I mean, the creating the index is only going to happen once. Creating the repo collection and index you could do together, and then when you insert, this is pretty simple. You're going to insert whenever you create a new repository, so that's fine. Then loading the collection and searching happens together as well. So those two are kind of joined, and this I'm actually going to move like this. So these two are joined. Okay, so let's go to the jobs repos. So after we upload the folder to MinIO, now we're going to actually now we'll start with this creating the records. So I need to import that embedding service. Here we're going to say insert. Okay. Collection name is going to be repos as well, so I'll just use the bucket name, or maybe just to be more explicit, it's going to be collection name. This is also awaited, so we insert into the collection there, and then we need to pass in the rows here. So this could be an empty row, an empty array for now, but basically what we need to do is take each of the files, basically that. So if we have here like rows, we're going to need to loop through all the files within that folder path, embed each file, and convert that embedding into a row object that has a name and a file ID and all that stuff. I'm going to take a quick pause on this logic and come back to it, and then we continue from there. Okay, I'm back, and it's time to continue with this part here. So what I'm going to do is I'm actually just going to insert some dummy rows so that we can see that it's actually being inserted into the database. And once we have everything inserted, then I'm going to use a GUI tool to see the database and actually confirm that everything's inside there. And the reason I'm just going to do that is just to see everything's working, and then we can come back to completing all this logic, because there's quite a few things that need to happen. First, we need to map the rows of the embeddings to the files that are created per the files that come from the service. All right, so we're getting all the files. We need to embed all those files as vectors, store all those vectors, and everything has to match in the database, because right now we don't even have a schema, right? We haven't done any schema yet to actually store a file object or file reference and also a repository. Right? None of this is actually being persisted, so it's kind of difficult to navigate and make sure everything is connected to the right places. So let's just create some example rows here, and I'm just going to go back to the example so that we can see what this looks like. Okay, so I'm using example vectors here, and they're using a 128 dimension. I just want an 8 dimension. 4, 5, 6, 7, 8. Right, so the vector is 8 dimensions. We'll obviously use something quite bigger, I would imagine. And let's just double check. What do I have here as in the embedding service? Our dimensions are also 8. Okay, so we'll come back to this. Okay. All right, so we have our vectors here, And now we need to map these to the fields, right? So we have ID is auto-generated. We have repo ID file, content, and metadata. So it's going to be like this. Okay, so the repository ID, this is just an example value that doesn't exist yet, and this would map to the ID in the repo table, right? And then this would map to the file table. The content would be some content for all the file content, right? So ideally we would loop through all the files that we get from the get service, right? So we get all the files, read all the file contents, store them as rows like this, and then the metadata would be an object with whatever metadata you want to include. So height and name are not required, so we can just do this. Okay. And then this is going to be rows. Right, so we're embedding it or passing it into the embedding service. And yeah. Okay, so let's just refresh everything here. I'll also restart this one. And then I'm also restarting the containers. That's why I'm getting a no connection established over there, because the container wasn't running. Okay, looks like everything's back up. This is also refreshed. Okay. All right, so this is the job that gets triggered. So let's just run through the whole process again, trigger the job, make sure that this job actually completes on trigger.dev, and then go from there. So I'm just going to go with another repository because I've already got that one. So let's just do a very simple one. Alright, so the mutation was fine. Let's go back to trigger.dev. Alright, so this one was failed. So let's just check here. No connection established. Okay, so after playing with some of these things for a while, I figured out what the issue was. And the issue is that I was using the wrong port for Milvus. So this is the port for gRPC, which is what I should be using. Whereas I was using the previous one of 9000 and something, which is for the REST API. So I actually need to be using the gRPC port like this. Okay, so after just tweaking a few things, probably some of the variables are different, but that's where we're at now. Okay, so here what I'm doing is I am creating the repo collection. I'm then creating the index, and then we have those vector rows, and then we insert those rows into the embedding service, and there we go. Okay, now if we just open up the embedding service here, nothing here has really changed. We're just now connecting on the right port. Okay, and here's our call to create the collection. Right, passing in a collection name now. So what I'm going to do is I'm not going to do the insertion step. I just want to do the repo collection and creating the collection and creating the index. So let's try this now. And I'm going to go with the same repository. And okay, there we go. So this run completed. Looks like it was fine. And really all we did was we just created the repo and the index. So going forward, we're not going to need to call this again. So I've kind of done this as like a one-time thing, just so that the collection and the index or the indices are there. So now I don't need to do that again. Would be ideal to have some kind of separate script that I could run to do this, but this was just the quickest way to do that. So, and also because we're not going to be creating collections, at least how I'm thinking about it right now, I'm only going to have one collection, which is going to be for the repos. So it's not like we're going to be creating collections all the time. So that's done. Now let's go back and do this again. And now what we're looking for is that the rows will be inserted. So we should also see this logging at the end as well. And okay, so this one failed. Okay, so this is now saying that collection not found, which is kind of confusing. So what I'm going to do now though is I'm going to use the Milvus GUI, which is this one here, I think. All right, so it looks like this, and then that way we can also just get some more insight into what's happening here. And I'm just going to use this command to run it. All right, so let's go into services here. All right, so it's going to run that, and it's going to have to pull the URL here I did not put correctly, so let's just put this correct. This is localhost. Okay, so it won't find the image, so it's going to need to run, it's going to need to fetch the image and build everything, so this could take a little bit of time. Alright, so the server started here, and what I'm actually going to do is I'm just going to stop the server for a second. Okay, so I've just copied the image, and this is so that I can add it to the Docker Compose here. All right, because here we have all these services. So that's the image. So I'm going to go and grab some of this. Okay, so this is going to be atu. All right, the image here. It's going to be atu like that. And let me just grab the command here. Okay, so this is everything. So I need to expose the port 8000. And I'm also going to make it depend on some of these other containers here. So this is going to be port, which I'm going to put it on something different, something like 95. For example, I need to add the Milvus URL, and this is going to be, I think I can do localhost 530. It should point to the correct container like that. Depends on which one's this. Milvus standalone is the one that it needs to depend on. So I'll do it like this. Okay, there's no command. So I'm going to get rid of that. And then I'm just going to run this file again. So just telling me that the detected host platform was not the correct one, but I'm just going to double check that the container is running here, which it looks like it is. And this is the other way around. Okay, so try this again. All right. And okay. Okay, so coming back to over here. Let's just take a look at this. And I'm actually accessing the URL through the orb service that I use for Docker. So in this way, I don't have to know the port or anything. I just go to my services. So the username was optional. I don't think I put anything in there. So let's try connect.
Okay, after some serious debugging, I'm not gonna lie, getting that Milvus R2 service connected was not fun, but that's, yeah, so it's done. We can head over there and just, right, so here's like the UI for, it's called R2, that you can then see your collections and stuff on Milvus. And you can see I don't have any collections. So I've just been debugging this to figure out why this command to create the collection has not been working, this one here. And then here we get unexpected error, string data type not supported yet. We have to use the varchar like this. So obviously somewhere I've gone and put string, which is like this. So I need to do like that. And I think that's the only one like that. So if I change this, we can try this whole thing again. And this is still debugging. So let's go here. Go back to runs. And this one is also max length property is missing. So at least now, I'm starting to get some of the information as to why this was not working in the first place. So I'm just going to go with an example value like that. Not sure what this value will be yet. So let's try this whole thing again. Hopefully this is the last time. Okay, that was completed. Let's go over here. Okay, finally we have a collection. And we get repo ID, file ID, content, vector, metadata, got an index here. Okay, so now that we have that, let's head on back here. And we can actually clean things up a little bit. So this is just going to return this. Close that. All right, so I don't need to do the collection and the index again, so everything else can come back, including the bucket name. And then we continue here with the vector rows. All right, so let's test this out and see that we can actually do this. All right, so is everything reset? I think. So try everything again. All right, that one's completed as well. Let's head here and go to maybe data preview. Okay, so basically, coming back to where we left off, the issue here was with Milvus and the data not being loaded. That's why we couldn't see it in the console here. So, for example, if I go to all the repos, data preview, then I can't see any data, even though it actually has been inserted, which I believe here is this 11 entities. So basically all we need to do is just go select it, and you can click load. By doing that, now it's loaded, and this is the same thing as this method here, load collection. So now if we go, we can see here it's loaded, and then it gives us the option to do the vector search as well. And then if you come to the data preview, then you can see those 11 rows here, and they've got all the content that we inserted, right? There's the vectors, metadata is just an object. So yeah, there we go. This is how we can confirm everything is there. And then if you want to unload it, then we can just go back here. We can click release. So by doing that, it's no longer available for search. So you can see it's not showing up here. And if you went back to preview, then there's no data. So that is now all cleared up. Okay, now we need to go back and fix the insertion here. All right, so this part is fine. I'm just going to clean the method up here. But when we're calling to insert, right, and we have all these dummy rows,
we don't actually want to obviously use these dummy rows. We want to use real data. So we need to create those entries, and specifically it's the vector itself. So we need to do an embedding to create the vector. So what I'm going to do is make use of a tool, which I'm just going to grab the link here, which is, okay. So this package slash framework called Axflow, which has a few, or 3 different sections, one for models, then you can connect it to your LLM, and then it's got this framework for kind of prompting. So if we go to the models section, you can go to the embedding, and you can basically use their embedding API to call OpenAI. Right, so it's basically just a wrapper around OpenAI. And so this is going to be pretty useful to do the generation. And then it's got a whole bunch of other stuff around prompting and specifically using it in React. Like it's got this hook here that we can use. So we'll come back to using this more, but for now, I'm specifically going to use it to do the embedding. So let's start with the installation. Okay, so that's this. All right, so I'm just going to install the package. And here they have an example of everything. So they've got like ingestion and then Pinecone, which is another vector DB. And you can also bring your own different parts to it, right? So since we're using Milvus, we'll have to connect that up in a different way. And then you can do like a stream on a specific configuration here using an embedder and a model and a prompt, and then this is called a retriever, where the retriever links to whatever vector database you're using. So it's got all, it's kind of the framework to put all these pieces together and actually use them for streaming, which is pretty cool. So okay, let's come back. This is still installing, but what you're going to need is your OpenAI API key, first of all. So we're going to need that. And then we can also take a look at how to set up the embeddings part. So this is this one here. I'll actually just copy both of those. And we're going to go to the embedding service and then just add those imports here. Okay, it's not 100% installed yet, so it'll just take a while for the types to come through. But we're going to need a method here to create the embedding. So I'll do create embedding. And this is basically going to use that, but I'm just thinking in terms of what we want to take in. Effectively, it's just the content, which would be a string, and then it's going to return like a number array, I would imagine. I also need to install this package as well to get the types going. And that should be, no, we also need to do models. So let's go and add that as well. Okay, so it's all 3 of those packages. And that should then include these types here. There we go. Okay, so just going to run the server and then bring it down. Right, so here we're going to do OpenAI embedding. And we just need to see, is it callable? No, it's not. And it has a run method. So it takes in a request and it takes in options, which are these options, and then returns a response. Okay. So the body's sent to OpenAI. This is going to take in So we need to see OpenAI's documentation for V1 embedding. So let's just open this and I'll copy this link. And then we come over here and take a look at this. So the embedding object index, this is, okay, create embeddings. So we need an input, which is a string or array, need a model, an encoding format, and the user is optional. Encoding format is also optional, but defaults to float, which is fine. So we basically just need the model. If we go to list of models, this is to fetch our list of models, but we can use one of the more well-known ones. And then the input is just the text. So I'm going to use this text embedding model, the ADA002. I think that should be fine just for now. And that should be it. Okay, so let's do .run. So here we've got input, which is going to be the content. The model is going to be this one here. Let's just see. Okay, so an argument for options was not provided. So this is where we need to pass in API key. This is going to come from our environment. API URL, these are all optional, and I don't think we need to include those. So environment is already here. This comes from here. And we're going to need to go and add our OpenAI API key, which means you're going to have to go and add it over here as well. All right, so just like that, save here, and this then OpenAI API key. Okay, so that will return an embedding, and the type here is a promise of a response. So I'm wondering, let's say I did this, I just said embedding equals to create embedding. Let's say I do embedding dot here, we'll do dot data, and then this is going to be an array. So I'm wondering, probably it's going to be worth just printing out everything and seeing what we actually get in that object. But okay, so this is actually going to be probably a list of embeddings. Let's see. Create embedding is what we need to use in our repo job here. So this vector is no longer going to be that vector value there. So we're going to have to do, first of all, we're going to have to loop over all of our files and create vector records or objects here for each of those files. So inside this get method, the upload folder is very similar to what I would like to do here, which is to create a method to fetch or basically just have all the folder or all the file paths. So if I did something like get file paths, then it would be the source folder is all I really need, and the prefix is also probably worth keeping in there. So I'm going through all the folders. If it's not a folder, well, if it is a folder, then we need to try and do this. Say get all file paths. And at the top over here, I'm going to do file paths like this. And instead of uploading the file, I want to append the file path into that array there. I don't need to console anything out here. I actually don't think I need to try anything either. It's just like this, and the object name. So I'd say this is the object path. Okay, so basically this will then return at the end those file paths. And the point here is that with all the file paths, we can then read the contents of that file and then create the embedding from the contents of the file. Right, so I need probably another method here, which is like read file. And this is just going to take file path. We don't need anything else. Okay, so this is going to return, just actually letting, I want to use the file system instead because, well, actually this is the MinIO service. So let's say read file local, and then we'd have another one which would be read file from the bucket, right? So taking in the bucket name, and then that would use the client to get the object. That's fine. But in this case, I want to just use the file system. So if I say read file sync, file path, let's do wait. Read file. I wonder if we actually do. If we just do it like this, it'll return the contents of the path. Let's go with this option. Okay. So we've got two methods. You read the file from MinIO and read the file locally. Okay. So let's start with this uploading the folder to MinIO, so that's fine. Here I was creating a partition, which I'm just going to comment out. Then I'm going to say the file paths equals to await. We're going to do MinIO service dot get all file paths is there. Get all file paths, and this requires the source folder, right? So the source folder is actually going to be, I need to get the local, source folder name here. Yeah. And then this is going to be empty to begin with. Okay, so we can test that out as well. I'll do await io.logger, complete getting all file paths. Then what we'll do is let's go with rows. And here it's already, you can actually see it's giving me some suggestion. It's going to be similar to that. So let's just do, here it wants to do MinIO service to get file content. We can just read it locally. And then this is embedding service. It's going to be create embedding. File content, I'm going to do MinIO service dot read file local. And that just takes the file path. So like that. This is also not async. So we just do file content, read file local. Once we have that, now we have a buffer. So we need to convert the buffer to a string. So let's do okay. So converting the buffer to string. The vector is going to be the vector that gets returned here. But actually, what I'm actually thinking is this is going to be the embedding response. And I'm going to make sure that I explicitly return a number array here. And here I want to basically return something like that. But this needs to be a promise. Okay. So the embedding response, we're going to return embedding response dot data.
but I do need to console log this out because I'm not sure what the embedding response is going to take or going to have. If we return the data here, you can see here it's embedding object array is not assignable to number array. Okay, so an embedding object, is that importable though? Okay, embedding object has an index of type object and it has embedding. So if we did dot embedding, all right, so this is going to be number array. There we go, number array or undefined. Yeah. So number array or undefined. Okay, that's what I wanted to return, because then the vector is a number array, which we can then pass in over here. The repo ID and the file ID are both still being statically defined at the moment. Here we're just redeclaring rows, so I can get rid of that. And here, let's see what's the problem with the types. Undefined is not assignable to type number. Okay. So let's just do this then. We'll say return this or an empty array. Okay. So that way it's always going to be at least an array. It will never be undefined. And we come back here, and so this is our rows. This is stuff that we don't need to do either. Creating the collection and creating the index is already done. We don't need to loop through that anymore. So here we insert it and then do it over there. Okay, there's a response. Okay, so let's give everything a try and see where we need to fix anything up. Let's go with over here. So just double check everything is running here. Need to restart this. I probably did not include it here. Okay. This one will need to be restarted as well. This is all fine. Okay, so that's there. I need to change my .env to include the correct OpenAI API key, so I'm going to get that and do that. Okay, I've set that. Now we can go and test everything out. So just copy this. Submit. Let's go over to trigger. And let's see what happens here. Okay, so this is just because the folder directory is not correct, basically. So it's uploading all the files here. I actually think this is supposed to be path. Get all file paths, and the source folder is actually this path here. Okay, so I'm back again, and let's just recap what's been going on so far. So what I've done is change the way that we read all the files. You'll see there's some tasks here now that have completed, but they take significantly longer because basically we're looping through all the files synchronously instead of asynchronously. So what I've done is in the get all file paths method, first of all, this is completely sync now. I've removed the async part, and you'll see here I'm just mapping through all the files. If it's a directory, we go inside. Otherwise, we return that file path, and this returns then at the end a list of strings, which are paths to all the files.
And we then just take that list, which we have here, file paths, loop through all of those, read the file contents. So now you have a list of file contents, basically. And just looping through that list of contents, we then create the embedding and push it into that row. And so this has changed a little bit to what it was previously, or from what it was previously, because we used to asynchronously create the embeddings and just await all of them. And that would be a lot quicker. But you can see I was getting some errors, and most likely this was because I was pushing the rate limit on the API, on OpenAI's API. And so far, doing it like this has not caused an issue. So I'm continuing off of this, but I am still getting one error, which is relating to inserting the rows into the DB, and which is actually over here, and that's because the length of the vector is too long. So if I come over here, there's a log over here which might be too small to read, but basically it says it's an illegal argument. The reason is that the length, which is 4,439 of the fourth string, exceeds the max length of 1,024. Right, and that's because the schema has a max length of 1,024. So what I need to do is I need to chunk that file, but that's a little bit too complicated for right now. Basically just breaking up that file into multiple files of the correct length or chunk size that is needed for the dimensions of the vector field here. So instead of going down that right now, because this is already taking quite a bit of time to just get this whole piece connected, I'm going to come back to the chunking later. So for the moment, all I'm doing here on the embedding is I'm just taking the first 1,024 characters. I think that would be, I'm thinking something Python. This is .slice. There we go. Yeah. First I was thinking Python, then I was thinking Zig. Okay, so that should return basically up until the maximum length of what we can take in. This is not meant to be on the embedding. This is actually supposed to be on the file content. So just fixing that, and then we can come back and try this whole thing again. So I'm using my small repository again with one file, since it's pretty quick to test. And we'll see what happens next. Okay, so a couple things. Inserting into the rows with the content has just not worked. It's always giving the same issue of the content being too long. Even with the chunking function now, where I'm specifically chunking the text so that it's in a reasonable size, within the size limit, which is, if we look here, the maximum length on the file content is 1,024. I've also changed the dimensions of the vector field to be 1536. So I've then gone on Milvus here and recreated the collection so that it matches the new schema. And then I've also adjusted the function here to do chunking, even though I said I wasn't going to do chunking. It's just a very basic one, which chunks the text into a size. And I even put this slightly lower just to see, and this is always just giving the same issue. So for now, I'm actually going to remove the content field because it's just causing too much of a block at the moment. The vector embedding is not the issue. So if I just add a random content here, this will go through fine, and there'll be no issue, which is confusing. But I've also noted that you can also insert from files. So here they have the examples from Python and Java, but the idea is that if you just upload the file to MinIO, which we're doing, and then you just pass, I believe like this here, you are just passing in a list of file names, and these are the paths to those files. So in theory, we could do this bulk insert by just passing the names of the files, and it would take those files and do the parsing, which I'm curious to see how this will go, but I'm going to leave this for the time being, and then come back to it. So what I want to do is try this again one more time, because now it's just using an example content. The embedding is still the same thing, creating an embedding off of the chunk, and we can also go take a look here. One other thing to note is that once you start with the chunking, this is when I was not chunking, and this is when I started using the chunking method, and the time pretty much doubles, and that's because most of the files are longer than 1024 characters. So you're going to chunk that file into multiple files of that length and then embed each of those files. And we're doing an OpenAI call to create the embedding, which I've also thought what we can do is probably try and use some kind of local method to create the embedding. This completed, so that looks fine. And then if I go to Milvus here, it's got 53 files, which looks correct. So one thing they don't do is so here it doesn't show the vectors for every row. There are vectors in there though. There's 100 rows in here now. This is just from different runs, but it doesn't show a created timestamp, so I guess that would be nice to add as well. Okay, so basically if we take a look here at Excalibur, we are up to here now. Alright, so you select the repository, store it in MinIO, embed the files in VectorDB. Arguably, there's a lot of improvement to be done on the embedding process. So embedding locally, right? There definitely are some methods to just create the embedding locally, instead of sending a request to OpenAI to create the embedding for every single file. So that's one thing. And then also researching that method to insert or bulk insert files directly from MinIO, which I think is probably the way to go, because they've also kind of made it clear that they use MinIO for a bunch of things. So this probably is the best way to work when it comes with to working with the files specifically, because you can just upload a large file to MinIO and then just tell Milvus to process the file. So that's where we're at the moment. The last thing really to add onto this is the actual database schema, which I've talked about before. Right, it's the repository table, the file table, and then these linking to the VectorDB, which is in Milvus. Because right now, if we go to our Prisma schema, right, we don't have a table for the repo and the file, and those are some quick additions that I can make as well. So I'll do that in the next session or screencast, where I can then have the tables, and then we can actually create those records, both the repository and the files, link those to the VectorDB, and then ultimately be able to view things in the UI so that we can see all the files in a repository, see all the vectors or embeddings for that repository as well. And once you can do that, then you're pretty close to being able to do these things here, right? Prompting and selecting those files and doing all those kinds of things. So that's not too far away. I think probably in the next screencast or two, we'll get through all of these things here.
And yeah, so other than that, thanks for watching, and I'll see you in the next one.